So let's talk about Lissajous patterns. Lissajous, Lissajous. The French never say an S at the end of their words. I don't know why. But so Lissajous patterns. And they are the patterns that are these frozen patterns that you just saw just a minute ago. So we have one electron dot. So here's the electron dot. I'm going to tell the dot, this is the x-axis, the y-axis. I'm going to tell the dot to go up and down and back and forth at exactly 60 hertz. And we talked about that just briefly when I was showing it to you. So if this electron goes back and forth and up and down in exactly the same way every cycle, 60 hertz this way, 60 hertz this way, you're going to get a pattern that looks like that. In other words, you're going to get a straight line. This is, of course, x equals y. If the dot is doing the same thing in the x direction and exactly the same thing in the y direction in time, synchronized in time, then you're going to get a pattern like this. Sometimes, as you saw. But sometimes the dot is, so we're talking about sine waves. Sine x, okay, and sine y. If these two are equal, then I get a pattern that looks like that. But that depends on whether they're in phase or out of phase. For instance, you can have a sinusoidal wave that's really a cosine function. And of course, we know how sines and cosines are related. They're 90 degrees apart, that is. This is a sine wave, and this is a cosine wave. We'll talk more about that when we do our AC experiment lab. So these are off by, this is time, and this is voltage, or whatever you want it to be. It's voltage here. They're off by a quarter of a cycle, or 90 degrees. They're off by 90 degrees. We know that so the sine, for instance, let's take a little table here. 0, 90, 180, 270, 300. So what's the sine of 0? 0. What's the cosine of 0? It's 1. What's the sine of 90 degrees? It's 1. What's the cosine? It's 0. Sine of 180 degrees is 0. And the cosine of 180 degrees is minus 1. The sine of 270 is minus 1. And the cosine is 0, and so forth. Then we get back to 360 degrees, which is 0 and 0. So these things are 90 degrees. We say they're 90 degrees out of phase. They're 90 degrees out of phase. If they were both sine waves, they would be totally in phase. And if they're totally in phase, you get this nice straight line. Again, this is one little dot going back and forth on the screen, back and forth, like a sine wave this way, like a sine wave that way. But if it goes back and forth like a sine wave and up and down like a cosine wave, what's it going to do? Okay, well, let's start here. So if we'll call this the x-axis and the y-axis. Okay, so if x is 0 and y is 1, that means the dot's going to be up here. And if x is 1 and y is 0, the dot's going to be over here. And if x is 0 and y is minus 1, the dot's going to be over here. And if x is and so forth, that's going to be here. Okay, so what's happening is this dot's going to go from here to here to here to here and back, and it's going to go in the form of a circle. So if you freeze this pattern so that it's going back and forth sinusoidally and up and down cosinusoidally, you're going to get a circle. But these are rather special cases, that they're totally in sync or they're exactly 90 degrees out of sync. In general, they're someplace in the middle. And of course, someplace in the middle between a straight line and a circle would be an ellipse. That's typically what you see on the screen until you get them synchronized. And so it's going to be it's going to be an ellipse, a line, a circle, or something in between. And if it's frozen on the screen, that's really all you care about. You don't care what it looks like, and whether it's a circle or a line or ellipse. Then you're at a multiple of the frequency from the line, which is exactly 60. So don't worry about what the pattern looks like, worry about that it's frozen. And that means that one frequency is a multiple or a simple fraction of the other frequency, and the frequency I'm talking about is 60 here. So that's it.